In this session, I am going to explain circular queue, that is using arrays and its also. What is the disadvantage of linear queues? Why I am taking circular queues? That is the question. Here I am going to explain what is the disadvantage of the linear queues. Time consuming. First one is linear time to be spent shifting the elements into the beginning of the queues. That means for this reason it will take more time. That is the time complexity in linear queue is more, and signaling queue is full. That means even if the queue is having vacant position, what happens, it will show it is full. Here in this diagram you can see here 0 and 1. In these two space I have deleted the elements. Here I can insert the two elements, but it is not possible. See here, next increment another element, say 66 into this element. We cannot insert 66 into the queue as the rare is crossed the maximum size queue, that is 5. There will be queue full signal. This queue status is as follows. You can see here. That means if I try to insert a 66 in next year, it is not possible because it is okay. The queue, it has no size. But here you can see in 0 position and in position 1, that is queue of 0 and queue of 1, both are empty, but I cannot insert 66 here, that is in 0 position or in 1 position. This is the main disadvantage of linear queue. Here, this difficulty can be overcome if we treat queue position in the index 0 as position that comes after position with index 4, then we treat queue as circular queue. That means the linear queue is merged into a first position, that is first and last position are merged. That means here you can see it is in the circle. That means you can see when the thread is in straight position, that is in linear position, if I make this one into when I join from first end and rear end, then it will become a circular queue. This is the advantage. In circular queue, if we reach the end for inserting an element to it, it is possible to insert a new element if the slot at the beginning of the circular queues are empty. Here you can see, yeah, that is there I have showed that here 5th position and 0 position I have inserted a 66 and 77 element. For this I am making r equals to r mod of 6, that is equals to 2. That is here I am inserting, I am taking. Now if we want, if we insert an element to the circular queue as count equals to max, we cannot add the element to the circular queue. So the circular queue is full. Here you can observe how it is shown. See here, initially front and rear equals to 0. Now what I am doing, I am adding elements into a rear end. As previously we have said, the insertion will always take from the rear and deletion will always take from the front end. Here in this 0 position I have added a one element. I am taking that one as count 1. Next 2, in 1 position 22, in 2 position 33, in 3rd position 44, in 4th position 55, and in 5th position count equals to 5. After that what I am doing, front equals to front plus 1 mod of 6, that will become 1, and rear equals to 5, count equals to count minus 1, that is equals to 4. Here you can see. After that what I am doing, once again same thing I am repeating. See, next same thing I am here I have deleted, in these two I have deleted, in these two I have inserted. Now what I am doing, I am inserting this vacant position. You can see 0 and 1. Now what I will do, r equals to what is rear rear is 0, 1, 2, 3, 4, 5. That is 1, 2, 3, 4, 5, 6 position. Then here I have told 5 plus 1, that is 6 position. 6 mod of 6, that equals to 0. Now R is moved to the rear position and count is moved to the 1 position, that is here 1 have been deleted. Now I have moved 1. Now I can insert an element. Here now you can see, now insert a new element, that is 77 and 88 into the circular queue. That is in previous diagram I have shown the circular queue status is, here you can see 0, 1, 2, 3, 4, 5, that is 77, 88, 33, 44, 55 and 66. Front equals to 2 and R equals to 2, because here I have incremented front and rear position. Then rear equals to rear mod of 6, that is 2 mod of 6, that equals to 2, count equals to 6. 6 position, 1, 2, 3, 4, 5 and 6. Now if we insert an element into the circular queue, a count equals to maximum, because it is the maximum position. It will show that we cannot add an element to the circular queue. So the circular queue is full. How I should implement the circular queues using a C functions? As previous, same steps also followed here, but there is a slight difference in declaring the variables. As usual, first we should declare the header files, that include all header file which are used in the program, and define a constant size with specific value. Next step, to declare all user defined function used in circular queue implementation. Next, create a one-dimensional array with above sized size int CQ. Here CQ represents what? Circular queue. If it is not prefixed with C, what it means? It is a linear queue. If it is prefixed with D, means it is DQ or double-ended queue. For identification, I am prefixing the values before the queues. Step 4. Once again, two variables I have required. One is front and rear. Why? Front is used to delete and R is used to what? Insert an element into a queue. Step 5. Implement main method by displaying menu operations list and make suitable function calls to perform operation selected by the user on circular queues. The operations are performed. See, here you can see in a circular queue, Enqueue is a function which is used to insert an element into a circular queue. In a circular queue, you can observe the elements, and the new element is always inserted at right position. Not in circular queues, in all queues also it is the same thing is done, that is insertion is always done at rear end and deletion is always done at the front end. The Enqueue function takes one integer value as parameters and insert that value into the circular queue. Now here you can see we can use the following step to insert an element into the circular queue. See here, front end and R end, initially it is 0. Now I am inserting an element into a rear end, that here it is R equals to 0. F of R equals to 0 is 11. The element is the value of an F of R, R of a 0. Next I am incrementing R, that is R equals to R plus 1, that is 0 plus 1, that 1 value is 1 mod of 6, that equals to 1. Here I am inserting another value. Initially count is also 0. Now I am incrementing count automatically, because I want to count how many elements are there in the queue, because if it is 6, then it is shows fill. If when I delete, then automatically I will decrement count by 1. That means a space is there to insert another element, because here I am to overcome linear queue. For that reason I am taking the count. Now you can see in step 1, check whether queue is full. Rear equals to size minus 1 and front equals to 0, or front equals to or plus 1. Then in step 2, if it is full, then display queue is full, insertion is not possible, and terminate the function. In third, what happens? If it is not full, check rear equals to size minus 1 and front not equals to 0. If it is true, then set rear equals to minus 1. Step 4, increment rear value by 1, that is r equals to r plus 1. Set q equals to r rear, that is q of size, that is front rear size, that equals to value, because I want to insert a value into the position of rear end. For that reason I have taken q of rear equals to value, and check front equals to minus 1. If front equals to minus 1, what happens? Then I will set front equals to 0. In circular queue, dq is a function used to delete an element from the circular queue. As I said before, enqueue is insert and dq is deleting. In circular queue, the element is always deleted from front position. This is position, and the dq function does not take any value as a parameter. We can use the following step to delete an element from the circular queue. What are those steps? Check whether queue is empty. For that I am checking the condition, if condition. If front equals to minus 1 and r equals to minus 1. When if it is empty, then display queue is empty, deletion is not possible, and terminate the function. Next, third step, what is? If it is not empty, then display queue of front. Front is the position where I want to delete an element, and then increment front value because I want to move to the next position. In diagrammatically you can see. For that reason I am incrementing front plus plus, that is front equals to front plus 1. Then check whether front equals to size, that is maximum size. If it is true, then set front equals to 0. That means when it reaches to maximum size, it will print what front it will assign the value front equals to 0. Then check whether both front minus 1 and rear are equal. Front equals to minus 1 equals to rear. That means I am comparing the statements. If it is true, then set both front and rear equals to minus 1, front equals to or equals to minus 1. Here you can observe. For displaying, what is display? Here there is only meaning in display. That means to display the content what are there in elements which are in the circular queue. For that, here I am showing the steps whether I should check before displaying any elements are there not. If front equals to minus 1, it will print empty. That means no element is there to print. If it is empty, then display queue is empty and terminate the function. If it is not empty, an integer value I, because from 0 position to the maximum position I want to move. That means I want to print the values. For that reason I am initializing a I as a variable, that is I equals to front, as I have done previously in where? Yes, that is in linear queue. Check whether front is less than or equals to rear. If it is true, then display queue of I. That means I is the position of where front is there value, and increment I value from 1, that I plus plus. Repeat the same until I is less than or equal to rear becomes false. Same steps what are there in the linear queue. What I have explained in linear queue, same steps also followed. If front is less than or equal to rear is false, then display queue of I value and increment I value by 1, that is I plus plus. Repeat the same until what it is I is less than or equal to size minus 1 becomes false. When it becomes false, set I equals to 0. Again display CQ, that is what are their elements in the front end, that is I position, values and increment I by 1 I plus plus, repeat same until where I is less than or equals to rare becomes false. Until that it will go on looping. In program I will show how it will work. Here you can see header file as step by step I have showed what are the function to be performed. One is the header file. Here I have declared it is for 5. I am taking through values enqueue, dequeue and display. See, these are the same functions which I have used in linear program. Same explanation. There is a little bit change. That is, what I am doing here r equals to or mod of that is this size r equals to that size may be 5. When it becomes, then it will move to the 0. Here I am initializing circular queue size. Here what happens, eq equals to 5. You can say front initially -1 and r equals to 1. And this is the main function. Here you can see I am taking the 4 values. One is inserting, deleting and display. For this I want to do repeatedly because until the size get is filled. For that reason I am using while loop. Then I am entering a choice. That means I am requesting a user to enter a choice. I am scanning the choice. After that I am moving the switch statement because there are 4 options I have given. One is to enter or insert, second one is to delete, and third one is display, and fourth is to come out of the loop, that is from wrong choice. If we enter more than 4, it will print please select the correct choice. After that it will come out of the loop. Here I am explaining how it is done enqueue. That is, here same thing what I have done in where linear queue. Here you can see only this condition I am using, front equals to 0 and r equals to size -1. This is called as a logical operator, that is AND operator I am using, and this both ampersand is called as an AND. When these two are is true, that means here both conditions should be obliged. That means front equals to 0 and r equals to size -1. If both condition is obliged or true, then it will do front equals to r plus 1, and what it is showing, circularize full and insertion is not possible. If this condition is false, then it will move to the else part, that is false part. If r equals to size -1 and front not equals to 0, this is also both conditions should be true. If any one is wrong, then this won't work, as I said in above. Now r equals to -1 c of q plus plus r, that is r plus 1 I am incrementing. When it is position is there, the value is inserted. Then after that successful insertion, front equals to -1, that is front equals to 0. That means I am assigning front equals to 0. Here you can see f equals to 0, r equals to 0, and I am incrementing. Here you can see c of q, that is plus rare, that is 0, and the value is 11. Next I am here you can see r equal plus r plus 1, that is 1 plus r, that is 1 plus 0, that is 1. Inserting an element 2. Similarly until here you can see in circular queue, that is 55, and fourth, that is last position I have came a rare, that is moved, and I am inserting elements in rare position. Then here you can see dequeue once again. If it is true, what happened, deletion is not possible, because when f equals to r equals to -1, see here I am, you can see the index value is always begin from 0, and here up to maximum size here I have taken as 5. But when r equals to -1, there is no space, that means no elements are there. Therefore circular queue is empty, deletion is not possible. When this condition fails, again it moves to here I will delete the element and I increment the front. Here there is no necessary to increment the rear because rear is always used to insert an element and front is always used to delete an element. Here you can see front equals to front plus 1 mod of 6 r equals to here fifth position count equals to 4. You can see 1 2 3 4. Here also you can see r front equals to front plus mod of 6 that equals to 2 and rear equals to 5. Count what happens, 1 I have deleted, 1 2 3. That means I am decrementing simultaneously, I am decrementing the count. While inserting simultaneously I am incrementing the count, while deleting simultaneously I am decrementing the count. Here you can see for display front equals to -1. If it is -1, it is known thing, circular is empty. Otherwise I am assigning that front is less than or equals to rear, while I is less than or equal to rear, that is the value, then it will print all the contents which are there in the queue. See, this is what conditions I am using. While I is less than what, it will print. Then I am initializing. When condition is get false, I am initializing I equals to 0. When it is less than or equal to rear, it will print the values what are there in the circular queues. See, here you can see the output: insertion, deletion, display, exits. One choice 30. Next insertion successfully. Next it is go on. I have inserted 3 elements 10, 20 and